Dear viewers or students, now in this video we'll deal topic which is asked not only in class 11th and 12th exams but also in certain competitive exams like NEET or your medical and entrance exams of engineering. And this is a very important topic, that is fractional oxidation number. Now, although we have dealt in the previous videos that the oxidation number always comes out to be in a whole number, but there are certain compounds where you will see the oxidation number of an element to come out in fraction. Let's see here a compound C3O2, carbon suboxide. If we try to find out the oxidation number of carbon here, let's assume it as again as X, so it will be 3X plus oxidation number of oxygen is -2, that is -2 into 2 is equal to 0. That is 3x is equal to plus 4 and x will be equal to 4 upon 3. So this is the fractional oxidation state of carbon in C3O2, that is carbon suboxide. Again, let's check out one more compound, that is a tribromo-octoxide. Bromine oxidation state, we will assume it as x, so that will be 3x plus -2 into 8 equal to 0. So it will come out to be 3x minus 16 is equal to 0 and x will be equal to 16 by 3. So in both these compounds, we see that the fractional oxidation states of carbon and bromine has been obtained. So this idea of fractional oxidation number appears to be very, you can say, not acceptable, because electrons are never shared or transferred in fractions. So this does not appear to be more appropriate or convincing. So, but this can be explained as this oxidation state is not of a single carbon atom, but it is the average oxidation state of the element under examination in a given compound. That is the averaging of the different whole number values of the oxidation number of different atoms of the same species present in the same compound. Now let's check out in both these compounds by their structures. If you will see the structures, then we can clearly say how this fractional oxidation state of these elements have been obtained. So let's see here, this is the structure of carbon suboxide, that is C3O2. Now how we will see the oxidation state of each carbon will be different here. For each bond, okay, for each single bond, we will see electropositive and electronegative atoms. So electronegative atom will acquire a -1 charge and electropositive atom will acquire a +1 charge. So here are two bonds. So for this bond, oxygen will have -1 charge and carbon will have +1 charge. And for this bond, it will again have +1 charge and this will have -1 charge. Now here again, oxygen is more electronegative, so it will have -1 charge and +1 charge carbon will have for this bond. And for this bond, it will have again, oxygen will have -1 charge and carbon will have +1 charge. So here the total charge will be +2, -2, +2 and -2. Now for this carbon, because it is attached to similar atoms here, so this bond, because both the atoms are similar, there is nothing as sort of more electropositive or electronegative atoms, so it will have a 0 charge for each atom. For each bond, there will be 0 charge here, 0 here, 0 here and 0 here. And for this bond also, 0 charge here, 0 here and 0 here and 0 here. So on summation of this, you will get as oxygen -2. This carbon will have +2 charge. This carbon will have 0 oxidation number. This carbon will have +2 oxidation state, and here this oxygen will have -2 oxidation state. Now average oxidation number of carbon will be equal to 2 plus 0 plus 2 divided by total number of carbon atoms are 3, so we'll divide it by 3 and it will come out to be 4 by 3. So it gives you the average oxidation number of all the 3 carbon atoms in the compound. This is not the oxidation state of a single carbon atom. Otherwise, you can see as these 3 carbon atom different oxidation numbers, and these are in whole numbers. It is in carbon is having +2, and the third one is having 0 oxidation number. But this average oxidation number, it may be in fraction because it shows the oxidation number of the different atoms of same species present in the compound, and if you take out the average of these oxidation numbers, then we will get a fraction. Again, another example you can see here is tribromo octaoxide. Now again similar, we will apply this technique here also. For each bond you will see the more electronegative and positive atom. For bromine and oxygen, oxygen is again more electronegative, so it will have -1, +1, -1, +1. Again for this it will have +2 and -2. I am summing it up, and for again these two bonds it will have +2 and -2. Here again -2, +2, -2, +2, -2 and +2. And for this also it will have two bonds are there, so I will take it as -2 and +2 and -2 and +2. Now in summing it up, what you will get, this bromine will have +4 oxidation state, and this bromine will have, again this will sum +2, +2, +2, it will become +6 oxidation state, and this bromine, if you sum up, you will get again +2, +2 and +2, that is +6 oxidation state. Okay, now we'll complete the structure also. I have completed the structure also, and you can see that this is double bond only. Okay, now you can see each bromine atom have different oxidation number. These two have +6 oxidation state, and it is coming out to have +4 oxidation rate. Now we sum it up. So average oxidation state here will be equal to, or oxidation number will be equal to 6 + 4 + 6 divided by 3, because 3 bromine atoms are there. So it will be 16 divided by 3, which is same as we have got here. So you can see that this average oxidation state, if it comes out to be in the fraction, it is not the oxidation state of a single atom, but it is the average oxidation state of the different atoms of the same element present in the compound.